I would like to welcome you to this webinar on reconciliation standardisation, the R Factor series. If this is the first time that you've really delved into any type of reconciliation reporting, I know firsthand it can actually seem really complicated, but I'm here to tell you today that it's actually a really simple concept. And if you walk away with anything today, I hope it's that the framework diagram that will help you speak to the factors. It's certainly helped me, and trust me, I do a lot of speaking about these factors. So we'll look at the diagram quite a lot throughout the presentation, and like I say, please hope you walk away with that. I also just wanted to reinforce that reconciliation has long been recognised as a key governance issue at most mine sites, acknowledged through the requisite reporting of monthly metal accounting information. And while most modern mining operations have a well-established month-end process, and we all pretty much do it, the resource sector has still yet to endorse uniform reconciliation reporting against which model accuracy and metal recovery can be formally assessed. So this paper goes towards formalising this process with prescribed reconciliation factors. So let's get into it. We will start by examining conventional mining reconciliation. We all need to be on the same page before I get into the framework. We will look at an overview of the F series framework, so those reserve ratios, before we start to introduce a new R series framework, so factors all around the resource model. I'll go through a case study from the El Limon Juarez mine complex in Mexico to demonstrate how the R factor series can be implemented to facilitate operational optimization over and above the F series reconciliation treatments. Before we go through into a Q&A session, and I will invite the co-authors of the paper, Taryn Elkington, Jeff Booth and Bill Shaw, to be available for any answers to any questions you may raise. So get those questions in. So let's start. What is mine reconciliation? It's the comparison between an estimated and measured value of tonnes, of grade, of metal, let's hope it's all three, at different points in the mine value chain. But what we're trying to do is identify any kind of resource estimation inaccuracies, any type of sampling errors, any poor plant performance, just to name a few. But in addition, we're looking to use these factors or this reconciliation for key performance indicators. So what type of information is needed before you even go into the trying to reconcile your numbers? We actually have the resource and the reserve models available on site. Let's actually reconcile and see how well they're performing. We have mine planning and grade control data. We have information from dispatch. So all of those haulage records, those source and the destination, where is that material going to? We're very interested in reconciling that data, as well as the daily and reconciled data from the plant. And so daily being the estimates and the best measure of the day, the reconciled data usually being the end of the month data. And of course, don't forget transport and shipping if your mine happens to go that far. We've had numerous case histories report how robust reconciliation techniques add value to the mining operations, and these reinforce the importance of regularly comparing tonnage, grade and metal data from the disparate and independent sources. From this process, ratios or factors, so just think of a factor. When I'm talking a factor, it's just a ratio between two individual pieces of data. The process, the ratios or factors can be generated to facilitate identification of production underperformance, their links to estimation, ore loss, dilution, there's quite a lot, surveying, met recovery inaccuracies, quite a lot of data can be facilitated through this reconciliation. So just to be sure, these reconciliation factors are not meant to be confused with mine call factors. Completely different. Mine call factors comparing the recovered and the unrecovered metal or product post-processing with the ore estimated from sampling. We're not talking about mine call factors, we're talking specifically about reconciliation factors. So to estimate and ultimately reduce error, metal must be balanced at various nodes across that mine value chain using the tonnage and grade measurements or estimates. So the first step of any reconciliation process is to formally select and define your measurement points. So here I've just got a list here of some basic measurement points that you might find on your mine, a resource model, a reserve model, a grade control model. You may have other models, that's fine. Ore control or your mine production, so what's actually coming out of the pit or the underground, the mine delivered. So according to haulage, what did they deliver to the crusher? The crusher received, the crusher weightometer, and then feed, what's going into the mill or the plant, and the plant production, what is that final metal being produced from your plant. Just want to step into the F-series framework now, and some of you may be familiar with Harry Parker's F-series framework, and so the intention of this paper is to extend that F-series framework. So comparisons made for reconciliation are usually calculated using these factors or the ratios, and logically any comprehensive framework should facilitate comparisons between your reserve, your mine and your mill production figures. Harry Parker's F-series ratios are often used in some form by mine operators, although they're rarely shared externally as formal definitions have yet to be accepted. We've seen some great examples throughout my career where I do see those F factors being reported, albeit internally. So this is the framework diagram that I was talking about that I hope that you walk away with. So whilst we had the table before, which was just defining what those factors are, I think to be able to put that into a diagram just gives it a little bit more meaning to me, and I hope to you. So what we're looking at here is the reserve model to the mine production, so the F1, so exactly what that table said, and then the mine production to the plant feed, and then F3 being the reserve model to the plant feed as well. So these factors can be used as good indicators of the operation's performance and have been increasingly used by managers and shareholders to evaluate the performance of the operations and to calculate the financial investments aimed at improving processes. So whilst F1, F2, F3, let's actually go into it a little bit deeper. And before I do, just note that we are talking around this reserve model. Okay, so you may have a different model that you're looking at on site. As long as it's a long-term model, that's what this F-series framework is looking at. So let's go in and have a look at F1. So F1 consists of comparing the mine production against that reserve model, and it's the depleted model for that particular period. So we're looking at the same period for what has been mined against what has been depleted out of the model according to survey. The F1 factor will measure the accuracy of the model with the understanding of the ore body and the correct separation between the ore and waste during the mine production. So it doesn't matter what we say in the model, how well has that actually been mined once it's been blasted and once it's being hauled out. A high value of the F1 factor, so think about a ratio, absolute perfect result would be 1, and I would never expect to see a 1. If there's a 1, there's something dodgy going on because we've got different measures at all stages. But a high value, so anything greater than 1, let's hope it's 1.05, indicates that the reserve model was conservative. Okay? Whilst a low value of the F1 factor, so less than 1, would indicate that there's optimism in the reserve model. When we look at the F2 factor, it consists of the ratio between the mine production against what was fed to the plant. Now remember, there's a lot of stockpiling going on between this mine production and this plant feed. So we've got mine stockpiles, we might have underground stockpiles going to mine stockpiles, going to ROM stockpiles. Then once we go through the crusher, we might have a coarse ore stockpile. We might have many coarse ore stockpiles. So just be aware that that mine production to the plant feed has a lot of stockpiling going on, and I will expand on that shortly. The F2 factor does provide a check, a really good check for the unplanned dilution of the material that feeds the plant. So it also evaluates the control of your stockpiles, and I'm referring to the movements, what goes on, what comes off a stockpile, and then the estimation of what's remaining on those stockpiles, tons, grade, and metal. But it's also going to evaluate the performance of this plant processing. So a high value of F2 would indicate that the values for mining were conservative, while a low value of F2 would indicate optimism in mining. The F3 factor will compare the reserve model to the actual plant feed. It can be obtained by multiplying the F1 and F2. So we can see here that F3 would equal F1 times F2. It will evaluate the precision and the accuracy of the reserve model in predicting the feed to the plant, with the adjustment of losses and dilutions through the process, in addition to evaluating the mine's ability to recover tons, grade, metal as predicted by the model. So we've got a prediction here, what actually happened when we got to the plant. An advantage of the F3 metric is that it does remove that sampling bias that often affects grade control planning. So we know that there's usually a grade control model, or maybe a grade control model or another type of model that's sitting between the mine production and the reserve model. So the F3 just takes out all of that, those sampling bias effects. So the F-series framework is really asking that question, did we meet reserve expectations for the month? And in a well-managed operation, supported by a robust reserve model, over time, the F-factor series should hover around 1. We can see here, typically it's 0.8 to 1.2. Accordingly, achieving sort of that near unity ratio, that near 1, means the reserve model predicts both mine production and plant feed production well. So we absolutely want to get it down to around 1, but not spot on 1, because that will trigger some questions to be asked. So that's sort of the F-series framework, and I wanted to go through that in a bit of detail because that is sort of foundation of these reconciliation factors. So now what we've done is said, okay, that's awesome, but how does the R-series, the resource model, fit into this framework? There we go, we pop it in right in the middle. And this is the picture I want you to take away, okay? It gives you those F1, F2s, F3s, but it's also then starting to say, what's happening with this resource model? Why not include the resource model as a reconciliation starting point? It usually drives the reserve model. So let's actually start to compare it all the way back, or all the way through the mine value chain. It will offer you an improved resource modeling and estimation opportunity. There's no doubt about it. It will give you confidence in your reserve model. It will give you all-inclusive cradle to grave reconciliation reporting. So what do I mean by that? All the way through your mine value chain, your resource model, your reserve model. We will throw in a grade control model here. We'll look at the mine production. We'll look at the crusher weightometer. We'll look at the plant feed. So all the way through, we've got opportunities to do some reconciliation reporting. Let's break down these R factors to get a bit more of understanding of what they can tell us though. Okay, the R1, the resource to the reserve model. So this really is that direct model comparison, and we're looking to the extent of how the modifying factors are changing over time. And that, what I mean by that is, what does it take to convert that mineral resource into, say, an ore reserve, which is then economically mineable as part of the resource. So it includes diluting materials and allowances for losses, which may occur when the material is mined. So again, just giving you confidence between the two models that the modifying factors are working, especially when we start to look at how it's comparing against the other nodes on this framework. The R2, the mine production to resource model. And here we're just looking at the measuring the cumulative impact of the information effect. And I'm talking about all that extra drilling we do between usually the resource model and by the time we're mining it. And also the dilution and ore loss. So, you know, it's not a perfect world. We do have to account for size of equipment and ore bodies sort of going off interpretations. So that dilution and ore loss, both planned and actual dilution and ore loss. But this R2 is demonstrating how well that resource model can predict your mining practices. It's also going to give you a little bit of insight into the impact of those geostatistical adjustment factors linked to assumptions in the mining selectivity. The R3, the plant feed to the resource model. Here we're comparing the operational, so operational, to the long-term modifying factor. And it's used for planning as it tracks both that short-term modifying factor for comparison against that long-term modifying factor, the R1. So we're getting confidence in this long-term, but we're also going to get confidence in this short-term if this R3 is near 1. So the framework extension, including this resource model, also provides some interesting additional comparisons, including, and not limited to, but including the R3. So here we'll look at the R3. We can see that it's the R2 times the F2, all about our actual modifying factors. But it can also be our R1 times our F3, which is all around those planned modifying factors, and perhaps those that has been adjusted for performance. And you can do that for any of these, actually. I've just chosen R3 as an example. Any of these factors can be further subdivided to offer additional operational insights. And for example, I've broke down the R2 to include a grade control model here. And so that's now given me an R2A and an R2B. And using that same equation, we know that R2 equals R2A times R2B. But now I'm going to find out a little bit more about what's happening between the resource model and the grade control model, and between the grade control model and the mine production. And we will use this, subdivision in the case study. It helps us understand the information effect, so that extra drilling to the grade control model, and then that dilution or loss between what we planned and then what we actually mined, just to give us a little bit more optimization analysis. Just as another example, similar subdivisions are likewise possible at the processing plant, and I've put in a crusher received, so the crusher weightometer here. And so now I can compare this F2 by the mine production, so what was mined, what was sent to the crusher, and then what the crusher has said it received against what the mill has received. Remembering loads of stockpiling between these two, and also maybe stockpiling between the crusher weightometer and the plant feed. So just a summary before we move into the case study. The mineral resource will not necessarily be mined as modelled. We all know that, unless the deposit is such that its selective mining is strongly controlled by the geological boundaries, or the lack of controls on the cutoff grades are such that bulk mining operations emulate that highly smooth resource estimate. And in such cases, the mineral resource and the ore reserve would be very similar within the volume planned for mining. But significantly, such factors may help demonstrate how well a mineral resource approximates its grade distribution as infill drilling is completed or as dilution or loss wanes. Now for the fun stuff. So we've got the definitions out of the way. Let's actually have a look at a case study that we did with Torex Gold Resources. So Torex is a Canadian gold producer. They're active in the Guerrero gold belt in Mexico with a principal asset of the El Limon Juarez, or the ELG mine. And last year they produced around 468,000 ounces of gold. And where my cursor is now is where ELG sits, and Mexico City is around here. It's 180 kilometers south of Mexico City, or around a 4-hour drive. There are 3 open pits at ELG. They're the El Limon, the Juarez, and the El Limon South. The El Limon Juarez underground mine is also very active, and all of this material feeds into a processing plant with a throughput design of about 13,000 tonnes per day with gold recoveries of 87%. So with a view to continuous improvement, Torex Gold strives to achieve leading industry standards in sustainable performance, disclosure and reporting, and has successfully, and I'm saying this, successfully incorporated the F-series reconciliation factors into their monthly reporting. So well done, Torex. This case study focuses on the open pit reconciliation of the operation, but similar processes are followed for the underground operation. And here we've just got a picture of the ELG loadout facility and processing plant. Another pretty picture, because we all like pictures. We've got the mining environment. So you can see a little bit different to what I'm used to here in Western Australia, a little bit more rugged, which I'm sure offers up its own challenges, but very scenic at the same time. And just to reiterate that Torex or ELG does have that robust F1, F2, F3 reporting system in place and has been using it for near on 18 months now. The ELG material movement flowchart with just some standard metrics defined on there. So we can see we've got a few different models. We've got the movements from the pit to ore stockpiles. We've also got material going directly to the crusher, and we've also got our waste movements. So we've got mine delivered being any ore material that's being delivered to crushers. Crusher received being that weightometer of both of those crushers. And then of course plant feed, anything after that dome or that coarse ore stockpile is considered plant feed. And then of course plant product we have down here. So we used these metrics, these standard metrics, to help us define the R1, R2 and R3 by incorporating this grade control and the crusher received numbers into the R factor series. So the F series results, and I don't want to dwell on it too much because it actually does paints a really nice story actually. The longer term F1 and F2, and I'll go into a little bit more detail, it does show a slightly over 1 for their ratio. And if we go in here, we'll have a look at F1 in particular. We can see it's over time, it actually is slightly over 1, which is giving us that slightly conservative reserve, which Torex agrees that they do have a slightly conservative reserve there. But they've also had a need for some stockpile tonnage rebalancing. And so whilst we don't see this in the F1, we start to see it in the F2 and the F3. We'll just have a quick look at this F2. And we can see that the F2 is the plant received to the mine delivered. We do only have a metal reconciliation reporting for the F2, which is fine, but again, a really strong visual to show that over time, we're trending over 1. And finally, we'll just have a quick look at the reserve model to the plant feed. And we can see here, this actually does, it mimics the F1 quite well. If when we go to the next slide, we'll just have another quick look at that. But what we can see is that we've got quite a bit happening here. It's sort of swings and roundabouts. We've got some tons being lower, then the tons become higher over a certain few months, and then lower again. So as I said, it sort of tells a really nice story, but what happens when we actually delve a little bit deeper into this data using these R factors? Is it going to tell us more? And let's just go here. Just before I do go on to the next slide, you can see this F1 and this F3 is mimicking each other. So what we've done is we've extended the R series reporting at ELG, and whereas that F series depicts how well a mine can monitor the reserve, the mine production and the plant feed data, the addition of that R series framework into this mine value chain will give us more reporting around the estimation and the mining practice understanding. So what's happening around this grade control model as well as this resource model. So to start with, we went, okay, what's happening between the resource model and the reserve model? And it's really clear there's not a lot. So with a constant R1 factor, global dilution and ore loss factors are readily observed to assist in the long-term planning. But you can see that over time, there's not been too much change to the modifying factors between the resource and the reserve. We've got a slightly higher tons for a lower grade and a near on par metal for R1, which is fine. It's just fine. So okay, let's move on to R2. So R2, we're starting to compare the resource model to the mine production. And I'm not sure if you can see it, but we certainly saw it. There's a threefold shift in this data here. And so when we look at it and break it down, we can see that to September 2019, tons, grade and metal produced by the mine were all greater than the resource model, reflective of the relative conservatism on the site. But this changed from September 2019 through to May 2020, when production tracked comparable tons. We can see here, this tons is looking pretty good, but the lower grade than the resource models. And then of course, after May 2020, you can see those tons and grade have realigned with the resource model, with tons marginally greater and grades marginally lower than 1. Let's break that down. So there's step changes in there. Let's try and understand what's happening. Now remember, we've got that grade control model that was happening between the resource model and the mine production. Let's break it down to that R2A and the R2B that we talked about in the definitions. So the R2A is the grade control to resource model, and it's tracking significantly higher tons over most of the pit life with lower grades after grade control. Okay, so orange line being the grades. So over time, you can see around here, the grades start to align with the resource model, indicating that the estimates have improved over time, which is absolutely what you want from your analysis. On the contrary, the R2B, so now we're looking at the grade control model to the mine production, they're consistently producing lower tons and a higher grade than the grade control model. And this is indicative of conservative mining practices to maintain the grade with an avoidance of excess dilution, planned or otherwise. And I hope that this shows you that by breaking down that R2, we're actually getting a little bit of a different story. So if you join them back together again, you get some discrepancies, but this will help understand what's actually happening. And so we did go back to Torex and we asked them what had changed, and they did give us some feedback, and I'll share that with you shortly. Let's just briefly look at the R3, so the plant received to the resource. And these factors, all the factors that we've looked at have coalesced into that R3 factor. So when I compare the R3 to the R1, we could see that the difference between the assumed, right? So that assumed modifying mining factors, and the R3 being the actual. And as the assumed here haven't changed much over the last 3 years. Remember that chart that we saw, it was pretty steady. Any variation in these F1 factors is due to prevailing outcomes in the open pit operations. Okay, so we're happy with what's happening here. We're not happy about is what's happening around these grade control models. Well, we're not saying not happy, but we need to understand more about what's happening around those grade control models. So by extending the F series framework to include the R series and examining the resulting reconciliation trends, it was noted that the improvements in the estimation of tonnes and grade in the modelling was due to adding that information from that infill drilling, so more drilling after the reserve into the grade control, and also the separation of the AusIMM pit into 2 different structural domains to improve the estimation parameters. So there has been a lot of work done around that, the way that they're estimating on those models. It's also noted that the heterogeneity of the skarn deposits tends to reduce when mining reaches the center of the deposit. So again, it's learnings about what's actually happening in the pit. And these do contribute to more reliable predictions. So we haven't put a dollar value and we haven't presented it for the improvements seen in this case study, but it becomes really clear that when you're keeping your grade and your tonnes in control, that more predictable metal outcomes build your budget and forecast confidence, as well as creating operating efficiencies. So whereas numerous attempts have been made to introduce global reconciliation standards, only where they offer actionable insights are they likely to be uniformly adopted by the mineral sector. We don't want to be trying to report on something that's just meaningless. It's just another thing to report on. It's got to give us some value. And we believe that this new R factor series presents those new opportunities for standardisation. So with their ability to quantify the impact of the information effect, that extra drilling, the understanding of the ore body, the dilution and the ore loss, the R factor series can become quite a serious standard to be contended with. And with the introduction of such an extended framework, a more rational discussion of reconciliation benchmarking should eventuate. And if we're all talking the same language, we're all measuring the same way, then it does become much easier to benchmark how your mine is performing compared to Joe Bloggs down the road. So before we do step into Q&A, I would like to thank Taryn Elkington, Jeff Booth and Bill Shaw, who were all co-authors on this paper, and without their assistance, we wouldn't be here today, so thank you, gentlemen. And we would all like to thank Torex Gold Resources for providing the data for this case study. And now if I could ask the co-authors to put their webcam on, we are ready for some Q&A.
Thanks, Rayleen. I think that was excellently presented. I'm Bill Shaw. Our other panelist is Jeff Booth. Unfortunately, Tarrant Elkington hasn't been able to make it, so I've been asked to present the questions to the panel, which should keep me fairly well under control, I hope. So, excellent work, Rayleen. Let's kick off with some questions straight away. A question first off from George: the 0.8 to 1.2 F factors do they work for all different kinds of deposits? And here's Tarrant. So,
Jeff,
Rayleen, do you want to start, and we'll sort of alternate round with the questions?
Yeah, absolutely. So yes, I have seen the 0.8 to 1.2. That's typically tier 1 that we see with that robust reserve resource models in place, really solid mining practices. When we get down to the tier 2s, it can absolutely change. So it can be below 0.8 and it can be above 1.2, and that just means we've got a bit of work to do. But unless you know that, you don't even know that the work has to start, right? So if you can't measure it, how do you actually fix it? So that's what the reconciliation factors are all around doing, is actually looking to see how well your mine is performing at different parts along that mine value chain, but also looking for opportunities to get that value closer to 1, whether it be tweaking your model or changing the way that you're actually doing your, changing the way that you're mining, or maybe it's better stockpile control. We all know that stockpiles are out of control. Whether it's having more control on those, yes, there is definitely mines around with outside of that 0.8 to 1.2, but that's a decent tolerance to have, and it still gives you room for improvement, but you're not off track.
Thanks, Rayleen. We had another question asking whether plus or minus 10% was a reasonable tolerance, and other people have suggested, including Harry Parker, originally plus or minus 15% on a quarterly basis, or on an annual basis, quarterly basis for indicated and for measured and proved, and plus or minus 15% for indicated and probable on a quarterly basis rather than an annual basis. Let's go to the next question then. How can you be sure mine production values are precise? They often seem to be based on all sorts of dodgy measures and assumed tonnage factors. Likewise, the grades may be based on various types of resource estimates, even including polygonal. What difference does that make? Jeff, do you want to have a go at that?
Sure, thanks very much, Bill. My comment to the questioner would be as follows: as much in the way of QA/QC should be done on the measurement tools, be they weigh bridges or scales, truck factors. You can I think on a dependable basis, bring in a series of radar, if you will, scans to measure the volumes that are going into your trucks. You can put them on a scale and determine how well your truck factors are seen. Likewise, belt scales can be calibrated on a regular basis. So it really comes down to instrumentation. You really have to make an effort on a regular basis to ensure that your instruments, whatever they may be, on mass and or volume, are calibrated appropriately. Weigh bridges especially. That's what I would say.
Right, thanks, Jeff. Another one that came in: do you think factors such as these should be reported to the market? I know you've got a view on this, Rayleen. Perhaps I'd like to add something in first. I think that if we report the F factors, we have to ensure that we put proximal definitions all the time. Otherwise, we're going to end up with all sorts of jargon and nonsense being bandied around to Joe's six-pack, as Harry Parker used to refer to the general public, whereas we just want a simple, consistent approach. So proximal means every time, if you're going to use an F factor, you make sure that you explain what it is in simple terms, and then the terminology will start to coalesce. Rayleen, have you got a comment about public reporting?
I think I'll just refer back to a paper that Jeff Booth and I presented at the last Mine Geology conference here in Perth, and it's around transparency and standardisation in these reconciliation factors or reporting. And I went down this path of, Jeff said to me, how well is, you know, mine A comparing against mine B? And so I went off and I did a little bit of research, and I couldn't find the answers, which was astounding to me. I actually thought, I was actually shocked that people weren't actually reporting it. And I'd never gone down the path of doing that. So yes, I do think that it should be reported, but as you said, Bill, it has to be prescribed, because there's no point in me comparing, you know, and two big players, BHP and Rio Tinto. If BHP's talking about F1 being a reserve to mine production, and then Rio Tinto's talking about F1 being the resource to the reserve, that's meaningless. So it has to have some kind of prescription on the definition of what I'm looking at, so that I can compare different companies on how well they're actually benchmarking against each other. And I think it's important as an investor to be able to do that. Like, how well is that resource being mined? That's what you're asking me for my money on, based on your resource. Now tell me how well that has been mined. And that's what's hard to get out of any information on the internet, right? I was a normal person. I was a mum investor, went looking, and I couldn't find that information.
Thanks, Rayleen. This is a hard one from Mark. I think we'll ask Tarrant this question, because can you hear? Your mic's on, Tarrant. How do you reconcile back to individual feed sources? We might all have a view on that, but the question from Mark is, how do you reconcile back to individual feed sources?
Well, that's a good question. So I guess it comes down to whether you're actually reporting your raw values, or some sort of a balanced some sort of a balanced number. So you know, I think it's important to try and keep a sort of a parallel measure of the raw numbers that are coming into your to your systems, versus those that are that you are then recalibrating based off of some other manner, so that you can you know, appropriately do those comparisons.
Thanks, Tarrant. Jeff, do you want to pile in on that one?
I can only echo, actually, if I can, what Tarrant has said precisely. And another very useful paper for people, Rayleen mentioned some of these elements here, but there's a very good paper from 2013 given at a AppCon conference, as memory serves me. And Bill, I think you are the principal author of that one. And I think all of those questions which we've asked here have been very ably, if you will, answered in previous versions of Reality. This is not the first time we've gone through this, so I can't add to any more than what Tarrant has already said, and I would encourage people to go through and just look at all of the options and how historically all of this has been treated over the years. And our co-author, especially Mr. Shaw here, has done a lot of this work.
Yeah, thanks, Jeff. Look, there are quite a few technical questions that are sort of coming through. What are we going to do about SG, and you know, how do we get the density right? Keep in mind, and this is my answer to the question that Tarrant and Jeff have already tried as well. Keep in mind that this is not a solution to everything. This is a framework, and you still have to have good data. And the good data means you have to, if you're blending from 3 pits into a plant, you've got a very complex system happening there already. Having a set of multiplication factors isn't going to give you the immediate solution to that. You have to create other forms of analysis, like doing batch processing for a little while to isolate where the problem might be. We'll go to another question, I think. Oh, this is an interesting one from Janice. I'm a qualified management accountant and mine geologist. Why is there no conceptual framework for the industry? Is anyone working on this? Rayleen, what would you say to that? Turn your microphone on, please.
Sorry about that. Yes, I'm aware there are people working on it, but I've yet to see anything. Okay, so this is, as Jeff and Bill and myself have been talking about for many years now, we do need a framework, and it does need to be available to everybody to be reporting against, and it should be prescribed. But no, it has not, but I'm ever hopeful that it's in the pipeline. That's all I can say.
I think you're doing a sterling job of driving it forwards, Rayleen, with the papers that you've written, and certainly Snowden's been doing this work for a long time, in various ways. We've got another question here from Bryce. All losses due to inaccurate markouts of the post-blast muck pile appear to be a significant source of discrepancy between the planned and actual tonnes of ore we see arrive at the mill reconciliation. Please comment on methods of using in-situ geological models to create the most accurate block model of this muck pile. Okay, I think that's a sort of a question about blast movement as much as anything. Jeff, you're nodding. Do you want to talk about the latest approaches to blast movement?
Listen, I can. Bill, it's been a topic of mine for many years. There, of course, the use of BMM, i.e. the balls, which people will place in the blast holes and follow up and get some indication of exactly where the ore body has gone. That's been around for some time, and quite happy to recommend use of them. Right now, I would say the front end, the pointy end, if you will, of this particular work has all been relegated to machine learning. And what people are doing is actually watching, be it photogrammetry or contrary-wise, with actual pre and post figures. You're watching where the muck pile is going and from where it is, where it was originally in situ. And the machine learning techniques, which are being used right now, are really front and center of where I think we'll be going in the future. It's not to say that the physical modeling won't be there, but my suspicions are that things like gradient boost, amongst others, will be a way forward to determining exactly where your muck pile, or how to reconstitute your muck pile after the blast. Still a work in progress, not easy.
Okay, I'll move to another question. These two are linked and they're both from Ian. Do you survey the monthly ore mined volume to see if your model SG is a factor in your reconciliation process? Perhaps he means it's a problem rather than a factor. And do you find all your reconciliation appears to be based on ore weight? So how do you adjust for wet and dry ore tons in the feed? Taryn, do you want to comment about this business of tons versus volumes and densities and surveys and things?
I might pass to Rayleen on that one, I think.
Sorry, I'm giving you the hard. I'm giving you the hard one, Taryn.
I was going to say I might pass to Jeff because he's been operational over the last number of years, whereas I've been looking at the end result, so I'm not involved in the actual getting that data together. So Jeff, sorry to do the second hand ball to you.
No, that's all right.
It's a pleasure. I would say the following. Density measurements and ongoing ones in terms of calculated versus what are reasonable are done or should be done on a monthly basis. So you've got your truck factors, you've got your volumes, you've got to assume a density after the fact basis, weighbridge or contrary-wise, a belt scale. So you're constantly working back and trying to balance this to see as to whether or not that's right. As for wet versus dry tons, we always work in dry tons if at all possible. So you have to go through and get a moisture estimate on a regular basis. This is done using the core samples originally, and one would hope as they come out of the ground. I most recently come from a nickel laterite deposit where water is a huge problem. and determining density, which can be up to and including 20, 30, 40% on any individual day, averaging maybe 16, 17, 18%. Can be problematic depending upon the weather. So you really, really have to be doing continual measurement. As I said before, calibration, very important. So you're doing weigh scales, your weigh bridges in your trucks to make sure that they're being accurately monitored. You're getting your volumes correct, and over time, your density, true density, should fall out. Remember that density, and it can't be said enough. I've done a lot of work around the planet. Most of the problems that I've seen in terms of reconciliation invariably come back to one of about 3 or 4 different things. It's geology and the resource model. It's density, okay? So people haven't estimated the density properly, and that comes back through to broken bulk density and or bulk density. And regrettably, getting the volumes right, picking the pit up properly afterwards. It's a big issue. It just can't be said enough, being precise in all of your measurements and making sure your instrumentation is working well.
Yeah, certainly drone surveys are making a big difference, like cavity monitoring surveys underground are making a huge difference now. But I think what we're seeing in the specific nature of these questions, Rayleen, is the fact that you've produced these line graphs which show trends, and people are now saying, oh, well, we understand what happened here and here. You know, what's the solution to this problem? Perhaps it's really change one variable, see what happens for 3 or 4 months. What do you think, Rayleen?
Yeah, I agree. You know, try and hone in on what you think is causing that variance to move away from that, you know, that on par one, and try something. You know, you're not tracking well now, so try something that you think will improve it and see how that has an impact on those charts, you know, and be looking at trends in time. So don't be looking at that 1 month in isolation. You know, that's not going to tell us a story. It might tell us a story for 1 month, but put it into context, put it over time. You know, even as little as 3 months is still better than that 1 month in isolation. And if you can push that all the way out to a year, even better. You're going to get more of a story about what's happening and the impact of those changes that you're making.
Excellent. We've got so many questions starting to pour in, which is just excellent. How are we going for time? I think we're doing okay for a few more questions. I had a question come in. Do you find the F and R factors confusing? Wouldn't it be better to use plain English language, Rayleen?
Why would we do that? It's mining, it's acronyms, right? You've got to make them up. Look, we've tried to keep the R series, the resource, R for resource. That's how I think of it. Yes, I found F confusing, but I don't know whether F was for factors. I don't know. But you've just got to remember the F factors. And then the R is the resource. And hopefully that will now trigger you to go, oh, I know what the R factors are. It's just a case of learning more acronyms. Yeah, so you can call them the resource factors, you can call them the reserve factors if you want. Totally up to you.
And Bill,
I'll come up with another one for the grade control model.
And Bill, I think that if it was what it took to get a standard set of definitions, that people just used the plain language and people all understood exactly what was being measured by each of those, then that's a win too. You know, there's no need to be precious about the nomenclature, you know, of the nickname, I guess, of each of those items. I guess it's working in with the most common one at the moment being the F series and trying to build off of that. But if people, I think it's probably equally as valid to state the plain language of what you're talking about. And even in that case, you do get down to questions of definition of you know, what is, you know, mine production, or what is your long-term versus short-term you know, depletion. But I think it's, yeah, I think that's the main thing, is that there's a set of common definitions, and that those cover the range of isolation, you know, isolated areas that we've been, you know, that Rayleen's talked about in her presentation.
Good. Look, I apologise for all the people who are asking questions if they think I haven't got to their questions. It's sort of jumping around a little bit for me here. But and we seem to have a lot of people with similar names coming up. So, what specific instrumentation or software in collecting the data in grade and tonnes has been used? This is from Hector. Do you want to say anything about that, Rayleen? I think people are asking about specific details for collecting tonnes and grades, but aren't we talking more generally, more generically at this stage?
Yeah, so I think you know, I'm probably biased because I work on Reconciler, but when I speak to clients, they've generally got you know, a model in one of the modeling packages, be it Vulkan, Studio, Serpac, whatever it might be. As long as you're doing the depletions on a monthly or a periodic basis, and you can then compare it to the same period in the mining, and whether that mining data is coming through from a haulage system, or as in a database, or if it's just being captured in spreadsheets, it's still better than nothing, right? You've got to track, you've got to monitor what's being mined. And then if you've got a plant historian, you know, getting data out of that, or even just using the reconciled number at the end of the month that the plant gives you. If you can actually get that data in a way that you can then compare it for that analysis, that reporting of those F1, F2, F3, and the R1, R2, R3, then you know you're in good stead. Now there are solutions out there that bring all of that data up so that you can analyze and report across that mine value chain, and you know that's something that Reconciler does. But you can do it all through spreadsheets, okay? Which is why everybody comes to me, because they've got these massive spreadsheets doing exactly that. So, you know, you can get it all into a spreadsheet and do the same calculations, or you can get an off-the-shelf product that will do it, you know, press of a button.
Well, you're going to be very busy now, Rayleen, because we've had 340 people register for this free seminar, and they've all got questions. We'll have just one more question. Before we do, I'll just make a note that this webinar will be available to those who've registered afterwards, and there is a slide that includes all the references for some people who've asked about papers that have been referenced and mentioned. The last question from Amit is, what was the resource confidence on the data presented for the case study? Are we able to make any comments on that now that we've been through the R factors process, Rayleen?
The resource confidence was pretty high, okay? I think that R1 that we looked at, where we saw that steady state from that R1, resource model to the reserve model, and the reserve model to the mine production gave us a really good story as well. The differences were when we hit that grade control model. So we've got high confidence in the resource model, high confidence in the reserve model, and then we started to see some discrepancies around what the resource model to the grade control did, and then the grade control to the mine production. And if you recall, that was where the tonnes was higher in the resource model to the grade control, but then it became lower because of that, you know, the careful way that they were mining their material, which is great to preserve that grade, but at the expense of losing some tonnes and so forth. So yes, the data told us that the resource model was looking really good, and also that the grade control model was looking really good, but maybe they didn't need to be so conservative, you know, with that mining.
Thanks, Rayleen. Look, I think that's it. Kelvin has been organising us for the AusIMM. I think we'd like to thank the AusIMM, all the questioners, and my co-authors and presenters, and particularly Rayleen for pushing this very hard and becoming a real champion for reconciliation globally now. And there aren't enough people doing this, so please all get on the team and keep in touch. Rayleen, would you like to close off with anything?
No, I just appreciate the attendance. It just shows how hot reconciliation is at the moment, and that comes with having a really strong resource industry, both here and internationally. And I just would like to say thank you for taking the time out of your day. And yeah, all the contact details for us will be on the presentation.
Okay, well, just hand back to the AusIMM to Kelvin now. Thank you.
Thank you very much, and a big thank you to Rayleen for today's presentation, and also to Bill, Jeff and Tarrant for joining our Q&A. Thanks everyone, we hope you enjoyed the webinar and we really appreciate you joining us today. And thank you to our destination partner and sponsor of today's webinar, Business Events Australia. If you enjoyed today's presentation, I encourage you to find out more and register for our International Mining Geology Conference being held in Brisbane and online on the 22nd and 23rd of March. We also have a special offer for you today. If you buy the conference registration and the AusIMM Associate Membership Bundle, you could save up to $172 and access year-round member benefits. More details about our fantastic keynote speakers and technical presentations are available at the conference website at ausimm.com/mining-geology. Thank you, and we hope to see you in Brisbane or online in a few weeks' time. Have a great afternoon.
Thank you.